important part of SOC Online. So, what is an interrupt? Anyone like to answer that? Okay.
Can you explain to us?
Okay. So, interrupt is an signal. Interrupt is a hardware signal or an event that is transfer the execution of sequence from the normal flow to an alternate flow of sequence. What do you mean by that? As we all know, SOC contain many components uh, which work together or independent processor, HBM, DMA, decoder, encoder, SRAM, PCI. All these components work together or they might be working independently to achieve a desired applications, right? Now it may possible due to certain condition and an independent master or any device wants to notify the processor that something has happened and you need to look into that condition. Uh, so let's say for example, in processor executed some read and write transaction towards the HBM and the particular task is completed or the particular task is terminated or there are some error condition in that particular read write operation. So that device need to notify to the processor, right, that there is a error condition occur in that sequence. So this type of task can be done by the interrupt. It is clear what are the interrupts. If anyone has any doubt, you can ask me. Okay. Now there are we can categorize the interrupt into several ways, but in a broad way, there are two types of interrupt. One is hardware interrupt, and another one is a software interrupt. So, what are the hardware interrupts? Hardware interrupt is a signal from an external device that indicate it needs to attain certain condition from the CPU. Uh, so as I explained earlier, for example, let's suppose there is a device on which processor issues some multiple read-write operation. Now, due to that operation, there is a error condition in that particular device. Now, that device will generate an interrupt will that will be directed towards the CPU, and once the interrupt will reach to the CPU will know that there are some error condition from the previous read write operation. So those type of interrupts are known as a hardware interrupt. Now another type of interrupts are software interrupts. So what are the software interrupts? A software interrupt occur by the execution of dedicated instruction. For example, let's suppose we have write a sequence in which we are writing to 100 location of HBM, and once these 100 write transactions are completed, we will interrupt the CPU that the 100 transaction has completed, and because of this interrupt there will be a dedicated instruction or dedicated sequence will be executed which may contain 100 read transaction to the same location. So this type of sequence that we execute on the on the firmware type, it is known as the software interrupt. Now, triggering of interrupt. So each type of interrupt can be triggered in a different way, right? Based on the device that the interrupt is generated from. So interrupt triggering can be done in two ways. One is the level triggering and another one is the pulse triggering. So what is the level triggering? If you look it into the diagram I mentioned in the slide, you can see one is in once the interrupt IRQN is transit from low to high, it will remain high until it is forced to be cleared from the processor or not. Okay, so once the interrupt is asserted, it will remain high until it is forced from the processor to be become a zero. So this type of triggering is known as the level triggering. And if you look into the second diagram, in this diagram you can see interrupts occur or interrupt assertion happen for a limited number of clock cycle, or you can say one clock cycle, and it is already deasserted, and the execution of that particular interrupt or serving of that particular interrupt happen in the CPU execution state. So these are the two different type of triggering for the level triggering interrupt, which is level triggering and pulse triggering. Now move to the interrupt verification. So uh, so in the SOC online or in the SOC, we started our verification or we divided the complete SOC verification into multiple parts. First, as we all know, SOC is a very uh, big chip, right, which contain multiple components. So to reduce the verification time, we divide our complete SOC into multiple parts. For example, we divide PCI block, and then we divide into HBM block, or we divide our SOC with compute block. So we start the verification of this block first, and then we combine all these block together to start the verification of the complete SOC. So this individual block are known as a block level verification. So similarly for the interrupt verification, first we started with the block level interrupt verification, and then we move towards the complete interrupt flow on a SOC. Okay. So what happened in the block level verification? We create a dedicated test case which will generate a certain interrupt, and that interrupt will be served by the CPU. So for example, let's say there is a PCI subsystem. So for each subsystem, there is a dedicated address space in the sock space. Okay. So for example, let's suppose there is a address space for PCI subsystem start from 1000 up to 4000. Okay. Now it might possible that this 4 KB range, right, completely not occupied by the PCI subsystem. There might be a range which is unoccupied or unmapped. There is a no register map in between some this address range, right? So if you target those range, right, there will be no component available to that particular address range, right? So in that cases, to handle this kind of situation, we have one block which is known as a terminator. what this terminator block do, it will check all the transaction uh, targeted to the this particular subsystem and check whether this particular transaction which is targeted to the address range of this subsystem has a valid address or not, right? The address which we receive from the particular transaction lie within the address range or not, right? If the address lie within the valid address range, it will uh, pass the particular transaction towards the particular valid component or towards the particular valid register. If this if the input address is not within the valid address range, it will block that particular transaction and generate an interrupt that interrupt that will target towards the master, and it mentioned that the you are targeting to the address range which is not available in the subsystem. Okay, so this type of application based triggering of input interrupts we can do in the block level. uh, this is clear. Please let me know if you have any question on. Okay.
Um, sir, can you repeat your again, sir, the reverse slide,
Which part do you want block
the
level
slide,
interrupt in?
the
Okay,
slide 26, sir.
26.
Yes.
Okay.
Can you explain again from here because not understand about the starting.
Okay. You
Thank
want
you, sir.
to repeat from the start?
Repeat from the type of interruption.
Okay. Types of interrupts. Okay. So there are we can divide interrupts into broadly two types. One is hardware interrupts, another one is a software interrupts. So what is the hardware interrupt? A hardware interrupt is a dedicated signal which is coming from the external device which is present in our SOC, right? And that interrupt is need an attention from the CPU. Okay, so there is a dedicated signal which is connected from the device towards the CPU. Okay, so that
Okay.
type of interrupts are hardware interrupts. Okay, now what are the software interrupts? So software interrupts, for example, let's say you have wrote one sequence which write let's say 100 transaction towards HBM memory, and then it will read from the same 100 transaction 100 location from that memory. Okay, now once the 100 write transactions completed, a interrupt is generated toward the processor which will indicate that the 100 write transaction is completed, right? So that type of interrupt is known as a software interrupt, which will generate once the particular task or particular set of sequence are completed. So those type of interrupts are software interrupts. Now, triggering of interrupt. So each type of interrupt can be triggered in two ways. One is level triggered and another type is pulse triggered. Okay, so what are the level triggers? So level triggers interrupts are those interrupts once it is triggered, it will remain asserted until it is served by the CPU or it is cleared by the CPU service routine. Okay, and another type is pulse triggering. So pulse type of interrupts are interrupt which will generate during a short period of time. It it will assert it for a one clock cycle, and it will deassert after one clock cycle. For example, right? It will generate during a short interval of time, and it will deassert it. Okay, it will not wait for the CPU service routine to clear that particular interrupt. Okay, so these are the two type of interrupt triggering.
Yeah, thank you, sir. Thank you, sir. I got it.
Okay, uh, so next part is interrupt verification. So interrupt verification can be divided into three parts. One is a block level interrupt, another part is interrupt connectivity, and the last one is a interrupt full flow, which include configuration of the interrupt, triggering of the interrupt, and the serving of the interrupt. So in the block level interrupt, we create a dedicated test case which will trigger to a certain condition which caused the interrupt to be generated, right? So as I explained previously, let's suppose cover a scenario in which we are targeting to the address range which is invalid address range, right? So in a SOC online, each particular block or each particular subsystem has a valid range. If you are targeting a invalid address range, that will generate a error condition, and to let know towards the processor that you are targeting to the invalid address range, it will generate an interrupt towards the processor, right? And that way processor will know that there are some transaction towards the invalid address range, right? So this type of application based triggering can be done in a block level interrupt verification. Now, the interrupt connectivity. As we all know that SOC contain number of master and number of slaves, right? So each slave will have certain number of interrupts, right? Now all these slave have number of interrupts, right? So on a complete SOC online, there are more than 100 or 1000 interrupts, right? So we need to make sure that each interrupt is connected to the uh, processor, or each interrupt can be direct to the processor properly, right? So those type of connectivity testing, or those type of connectivity verification done in the interrupt connectivity part. Okay, so in this part we check that all interrupts which are coming from the subsystem are connected properly to the interrupt controller. Uh, for example, in the diagram you can see, right, there are multiple devices. Uh, Now each devices have one interrupt which is connected to the interrupt controller, and that interrupt controller again connect one interrupt pin from the interrupt controller is directed towards the CPU. So in interrupt connectivity part, we check that this part, right? The interrupt which are connected between device and interrupt controller. Okay. Now the third interrupt full flow. In the interrupt full flow, we will cover all the configuration which are related to the interrupt, and then triggering like interrupts, either it is the level triggered or pulse triggered, and then clearing of the interrupt, which is known as the serving of the interrupt. So these full flow will covered in the interrupt full flow verification part. Now next is interrupt in the song online. So in a system on chip or SOC, general, what is the interrupt process work, or how the interrupt verification is done in the SOC online, right? So first, interrupt is triggered by the certain system in a event or interrupt sources. Then interrupt is detected by the system peripheral model, which then assert is interrupt output pin and set is interrupt register at the same time. Now, then the interrupt is captured by the embedded processor and the interrupt routine is executed by the process the interrupt. Okay. After processing of the interrupt, interrupt status is cleared by writing to the related interrupt register within the peripheral model, and the module is ready to another interrupt. Okay, so these are the main steps that we consider while generating an interrupt and serving
Nói
an
thật với các
interrupt.
bạn chứ
Okay,
bây giờ trong cái tầm giá từ 6 đến 7
so
triệu mình
let's
chưa tìm được
take
chiếc
an
điện thoại nào
example.
ngon hơn cái chiếc điện thoại này.
So
Đấy, lát nào mà đấy anh em
in a
ngồi lên
shop
nghe
online there are
nó rơi vào tầm 7 triệu
thousands
rưỡi.
of
Thứ
interrupts
hai,
available, right?
giờ thì nó đã unlock được sim rồi, lắp sim thứ thoải mái, upload
And
quốc tế thoải mái
in
luôn,
a
giá nó lại cả
processor,
hay thôi.
there are limited
Một trong những
number of
đơn vị
pins.
bán điện thoại giá rẻ
Okay.
nhất trên thị trường bây giờ cho phiên bản
So
bộ
for
nhớ trong
example, in ARM
256
64,
GB.
there are only
Thế thì mình sẽ phân tích
32 pins are available in the ARM. Okay. So how we are going to map thousands of interrupts which are available in the SOC to only 32 pins of interrupt, right? So we need to encapsulate 1000 interrupt in such a way that the similar type of interrupt will generate a single interrupt towards the CPU. Okay, so that type of task is done by the interrupt controller. Okay, so what interrupt controller do? Interrupt controller encapsulate similar type of interrupt which is coming from the different devices into a single interrupt which will connect to the CPU interrupt pin. That is the task of interrupt controller. Now, there is another type of interrupt, or we can say hardware interrupt can be divided into uh, further, which is masked interrupt or unmasked interrupt. So, what are the masked interrupt? Once there is a register which is used as a mask register. What the functionality of mask register? Mask register is used to mask the certain interrupt, right? If you want to disable a per certain interrupt, right, or more specifically, if you want to enable or disable certain interrupt, there is a one register which is known as a mask register. If the mask register is set, the particular interrupt will be disabled, and if the mask register is clear, then the particular interrupt is enabled, right? So to control the interrupt enable and disable, there is a one register which is known as a mask register, and with the help of this mask register, we can enable or disable a certain interrupt. Uh, any anyone any doubt so far?
So how about the unmasked interruption? So for that we cannot control what difference between the unmasked and the masked interrupt?
So okay, so each interrupt can, like for example, right, in a SOC, you are verifying on multiple interrupts, right? So we cannot cover all the interrupt at a time, right? So we will start one interrupt at a time, right? In that case, we are disabling other interrupts. Okay. So to disable a certain interrupt, there is a one register which is used to disable that interrupt, right? So that register is known as a mask register for that particular interrupt. If there are let's say 100 interrupts, so there are a register which cover the 100 interrupts, right? So if you are disabling interrupt 0, then you need to write mask register bit 0 to disable that interrupt. Okay, and if you clear the mask register 0 bit, it means that the particular interrupt is clear or enable. Okay.
Yes, okay, sir.
Okay. Okay. Now let's discuss one example. Let's suppose there is a subsystem, let's say PCI subsystem, and there is a range which address range for the PCI subsystem. It start from let's say all zeros and up to 3 triple F. Okay, and there are some invalid address range available between this complete range. Let's say invalid address range is 2FF. Okay. Now, how the interrupt test case will looks like, right? So first of all, we will enable a certain interrupt, which in this case, let's say if you target an unmasked unvalid address, so there is an interrupt which will be generated, right? So first we will enable that interrupt. To enable that interrupt, we will write to the register mask with 0. Okay, so this will enable the mask register of that interrupt, and once certain transaction or certain write transaction happen to the invalid address range, then this interrupt will be generated. Now this interrupt will routed towards the interrupt controller, and that interrupt controller will generate the interrupt towards the CPU. As the interrupt is enabled, then the interrupt will route to the CPU, and once the interrupt reach to the CPU will um, execute interrupt routine. So what is the interrupt routine? So once the interrupt occur, right? Once the interrupt is received, so what CPU need to do, right? What CPU need to do once the interrupt is occur? Uh, it will check whether which interrupt is occurred, right, and why these interrupts occur, right. So this type of process will return in the interrupt routine. So once the interrupt occurred, to clear the interrupt or to serve that interrupt, one there is a dedicated uh, program or dedicated sequence written in the CPU, which is known as the interrupt routine.
So can you write it in the note, because sometimes we cannot follow it.
Sorry, can you repeat?
Like when you read the example, can you write it in write brief it in the note?
So can you visualize the example? That will help us to easy to follow the example. Because you said first it's hard for us to understand how the interrupt work.
Okay. Let's okay. So let's I will repeat once again. Okay. So there are three part of interrupt testing. Okay. To check the complete interrupt flow, you need to configure that interrupt, you need to trigger that interrupt, and once the interrupt is triggered and once the interrupt is received at the CPU, you need to serve that interrupt. Okay, so what here what we means by configuring the interrupt, that is to enable the particular interrupt and let us know which type of interrupt is, either it is a level triggered or it is a pulse trigger interrupt, or what is the priority of that interrupt, right? Either it is high priority interrupt, low priority interrupt, or medium priority interrupt. So those type of configuration is done first, right? Now after this configuration is done, now you will trigger that interrupt. So how you are going to trigger that interrupt, right? The interrupt will be triggered when the certain conditions are met, right? So for example, if there is a interrupt, let's known as a error interrupt. Okay, so once there is a error condition, then this type of interrupt will be generated. So we need to create a error condition. So in our case, let's suppose there is a invalid address available in the address range. Once a write transaction or a read transaction targeted towards the invalid address range, that is the error condition, right? So if you generate a transaction to the invalid address range, it will create an error condition, and due to this error condition, the error interrupt will be generated. So that is known as the triggering of interrupt. Now, once the error interrupt is generated, for example, let's suppose this is the error interrupt IRQL, right? So it is generated here. Okay. Now it is asserted and that this interrupt is routed towards the interrupt controller. So once the interrupt controller receives this interrupt, it will check whether this interrupt is level triggered or pulse triggered, or what is the priority of this interrupt, right? That we already configured in the first step, right? So once it is verified all the configuration related to this interrupt, then it will route this interrupt towards the CPU. Okay, so once the CPU receive this interrupt, now CPU at that time it might possible that CPU is executing a different task, right? So as soon as the interrupt received at CPU suspend the normal task, right? And then it move to the servicing of that interrupt, right? To resolve that interrupt, right? So how CPU is going to resolve that interrupt? It will execute interrupt service routine, right? So what is the interrupt service routine? Interrupt service routine, nothing but a sequence of tasks, that sequence of instruction that CPU need to execute once CPU receive a certain interrupt, right? So it is a predefined sequence that CPU is going to execute once it will receive the error interrupt, right? So what might be the content of that sequence? It might be that you need to capture the address on which the the transaction is targeting, on which invalid address, right? So you need to uh, capture that address, and once the address is captured, then you need to clear that interrupt, right? So here you can see, right, the interrupt is deasserted after the service routing is done. So in the service routing, we are clearing that interrupt. Okay. So in the future, if the same interrupt occur, right, to detect that same interrupt, first after the service routing is completed, we need to clear that interrupt as well. Okay. So this will be the complete flow. First, we need to configure the interrupt. Then we need to trigger the interrupt. How we are going to trigger the interrupt? If the certain condition is met, the interrupt will be triggered. In our case, if there is a write transaction to the unmapped address or invalid address location, it will create an error situation and the error interrupt will be generated. Once the error interrupt is generated, it will direct it towards the interrupt controller, and interrupt controller will verify that interrupt. How it is verifying? It will check whether this interrupt is enable or not, what is the priority of that interrupt, and interrupt is level trigger or pulse trigger. Once all the verification in the interrupt controller is done, it will forward that interrupt towards the CPU. As soon as CPU receive the interrupt, it will suspend its current working sequence and when it will move to the service routine, which is the serving of the interrupt. In the service, what will we do? We will do a certain step which is predefined step by the firmware or by the software. In that case, we will either capture the address of that invalid location, and after serving the interrupt, we will clear that interrupt so it can also detect in the next simulation or for the further simulation. Am I clear?
Yes, sir.
Yes, sir. We clear, sir.
Okay.
And
Yeah.
one thing that about the encapsulation of the interrupt.
Okay.
So the encapsulation, you say that when we only have you say
Okay.
for example,
Okay. Okay.
yeah.
Okay. So as we all know that SOC is contain many components, right? There are hundreds of components, right? So each component have multiple interrupts, right? So for example, let's say there are two devices. One is a HBM device and another is a PCI device, right? So from HBM device, there are three interrupts. One is related to the single bit error, one is related to the double bit error, one is related to the error response, right? Similarly, from the PCI device, there are single bit error, there are double bit error, there are error like slave error or any kind of error interrupt, right? Now these similar kind of interrupts, right? These three interrupts which are received from the HBM and the similar kind of interrupts are received from the PCI as well, right? Now, similarly, there are other devices like suppose there are decoder which will generate the similar type of interrupt as well, right? Let's suppose there is a single error interrupt from the decoder as well, single error interrupt from the encoder as well, right? So all these interrupts are the similar type of interrupt, right? So what interrupt controller do? Interrupt controller will encapsulate the similar type of interrupt into a single interrupt, which will be directed towards the CPU. So let's suppose one single bit error interrupt from the PCI, one single bit error interrupt from the HBM, one single bit error interrupt from the decoder, and one single bit error interrupt from the decoder. All are encapsulated into a single interrupt, right? So if any interrupt received from any single bit error interrupt received from the PCI, HBM or any other component will generate a single interrupt towards the CPU. Okay. Instead of generating four interrupt towards the CPU, it will generate one interrupt towards the CPU. Okay.
So for example, there are four device with send the same interrupt
Interrupt.
type.
Yes. Yes.
So the controller have to send four times that interrupt into the CPU, right?
Yeah. Yeah. So in a normal scenario, controller can what control if there is a no controller, right? So we need to connect each type of interrupt towards the CPU, right? So one uh, similar type of interrupt coming from the HBM, similar type of interrupt coming from the PCI, similar type of interrupt coming from the decoder. All three interrupts need to be connected to the CPU, right? So if we go in a such a way, then we required hundreds of interrupts that need to be connected to the CPU, right? But CPU does not have that number of pins available, right? So what will we do? We will encapsulate the similar type of interrupt into one interrupt. So in this case, three interrupts which are coming from the different component and have the similar type of functionality will convert it into single interrupt, right? And that interrupt will be connected to the CPU. So if there are 15 similar type of interrupt which is coming from the 15 different devices, right? So instead of connecting all the 15 input interrupt to the CPU, we will connect only one interrupt to the CPU. So all these 15 interrupts are encapsulated into one interrupt to reduce the interrupt pin count at the CPU. Am I clear?
So what is the priority of this interruption?
Yeah. So in the configuration part, we can set the priority, right? You want to prioritize the interrupt which are coming from the HBM, or you want to prioritize the interrupt which are coming from the PCI, right? We can set the priority for the HBM interrupt to be high, right? Similarly.
Okay, sir.
So do we have any standard for the interrupt controller, or each of each system, each of will have the different type of interrupt controller, sir?
Yes, 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 yes. So there are depending on the vendors, right? If vendor stock vendor is generally either they are going to use some IPs which are available in the market, interrupt controller IPs which are available in the market, or they can create their own RTL or their own IP to work as an interrupt controller. So mostly, generally, there are some IP like GIC, which is known as a generic interrupt controller, GIC 500 or GIC 700. Those are the interrupt controller, generic interrupt controller provided by the ARM, right? Or other IPs are also available, uh, which can be used instead of generating your own RTL. It's depend upon the application, right? If SOC application can be uh, covered using the generic IP, then we are going to use the IPs which are already available. Or if the application is not covered with or not cannot be executed using the generic IP, then the vendor will create its own interrupt controller based on the functionality or based on the requirement. So, for example, there are some generic interrupt controller which is known as a GIC, generic interrupt controller 500. The I think GIC 500 is provided by the ARM. So it is the Intel IP from the ARM. Okay. Any more question related to the interrupts?
I think no, sir.
Okay. I think we can conclude this session today. I think we covered all the interruptions. Okay. Thank you, everyone.
Thank
Thank you, sir.
Thank you.
Thanks, sir. Thank you, sir.
Thank you.